Hello everyone. I wanted to work this problem from the homework assignment. I think it was the most missed problem of all, and it has a lot to teach us. It is in fact another layer of abstraction that many of you encountered for the first time. So missing it was understandable. At what point at what point will the line passing through a comma negative 1 and a comma 5? At what point will the line passing through those 2 points intersect the line passing through negative 3 comma b and 2 comma b? Now if you remember on the homework PDF, I supplied a XY axis and suggested that you may want to use that to convince me of your argument. Also, I suggested in the discussion posts and in other places in this course that when you get stuck, that you run an experiment with real numbers. In this case, you would replace a and b with some solid numbers and see if that helps you get a handle on what the problem is about. And that is good advice, and many of you, to your credit, took it. And I think it will serve you well going forward as we approach some very difficult word problems. So I want to take my own advice and I want to run a number experiment. And in fact, what I'm going to do, as I said here, I'm going to let a equal 5, which is a nice smooth number. When I do that, the ordered pair a comma negative 1 becomes 5 comma negative 1. And a comma 5 will become 5 comma 5. Now, these 2 points are very easy to graph. And when I do that, when I draw them out, and then when I connect the 2 points that define a line with a solid line, we end up with this vertical line. Now, if you had chosen a different a, you would also end up with another vertical line. So verticalness is built into these 2 points. It can't be escaped from. And running the number experiment helped us get a handle on that. Of course, we still need to do the 2 pairs that feature b. And I've chose a user-friendly b. I said let's let b equal 3. In which case, my choice generated the ordered pairs negative 3 comma 3 and 2 comma 3. Again, very easy to graph. And when I did that, here's what the picture looked like. A horizontal line. Now, of course, horizontalness is built into this other second pair of points. And no matter what b you would have chosen, you would have got a horizontal line. And the question that's being asked here, of course, is about the intersection of these lines. Now, for this specific case, finding that intersection is very easy. You go over 5 and you go up 3. So the intersection is 5 comma 3. And a lot of you, this is where you stopped. You ran the number experiment and you said, hey, the lines intersect at 5 comma 3, or whatever the values that you ran your experiment with were. And that's the right idea, but not the complete execution. This problem is asking us about all possible a's and b's. They want you to think in general terms. And I want to show you why that is, where this is trending. So let me erase this. And let me drag in something, a scan from a calculus book. Now, if you're going on in math, college algebra or calculus, you're going to see a lot of figures in the textbook that look like this. Notice that the distance over isn't given in terms of a solid number. It's just a over. X is equal to a right here. And you go a over and then you go some distance up, and that isn't even given in terms of a solid number. It's given in terms of functional notation. If I was to write this ordered pair represented by this point right here, I would have a comma f of a. So the ordered pair is generalized. And that is what lies ahead of you. You need to think in terms of generalized ordered pairs. And you'll do operations on those generalized ordered pairs. You'll add them, subtract them, divide them, etc. So that's where all this is trending. And that's a good thing to get exposed to it now. So I want to rework this problem in that spirit. And what I've done to help us get us in that mood is I've brought in an XY axis that is no longer sitting on top of graph paper. There is no scale. We're going to have to supply the scale. And in particular, we're going to have to figure out where A is. And I say that A is that much over. I'm just making that up. I could have put it anywhere. But let's work in the first quadrant. So A is that much over. I need to do the same thing for a hypothetical B distance. and I'll let B be that much up. Now, the game is graphing these 4 points. Let's switch color to red, and let's graph the 2 red points. Now, we need to go A over and -1, A over and 1 down. That's going to be down here someplace. And it's all dependent upon my choice of scale. I'm going to say it's right about here. And now I need to graph that second point, which is A over and 5 up. That's someplace up here. And then, of course, what we want to do is connect them with a line. 2 points define a line. There we go. It's not perfect, but it's very close. Now let's switch colors and graph the 2 blue points. Okay, so I need to go -3. I need to go to the left -3. That's, I'll say, right about here. And then I need to go up B, which is right about here. And I need to show my point. Okay, now I need to graph this point, 2 over and B up. Oh, that's right about here. 2 over and B up. And then I need to connect the 2 points that define a line. And that looks like that. Pretty close. And now, we're at the defining moment. We're ready to answer this question. I've graphed these 2 points, and we're now ready to say what the intersection is. What is that point right there? And what is it? What is it in terms of A and B? And I think it's pretty easy to see. To get to that point, you have to go A over and B up. In fact, A over and B up is where these 2 lines, these 2 generalized lines, intersect. And that will be true for any values of A and any values of B. So that's what this problem was all about. It was another layer of the onion, another step deeper into abstraction. They wanted you to actually graph these quantities, A and B. And I know that was probably the first time many of you have ever been asked to do that. And so you stumbled, and that's okay. I hope this helped you find your way, and I'll be talking to you soon.